Hello, Conceptual Physics. Here's a specific example of how to make this calculation. So I've got my 10 centimeter mark set up on the left edge of my left cart, and I'm going to advance some number of frames until I can get a really distinct movement on the cart. So let's see here. The cart has gone from 10 to 6, so that is 4 centimeters in an amount of time that corresponds to 13 frames, or 0.1083 seconds. You can see that 4 divided by 0.1, I'm going to estimate here, which is what that little squiggle means, is about 40 centimeters per second. If you want to be fancy, we can say 0.4 meters per second. So they're going pretty fast. If I wanted to calculate the momentum of this cart beforehand, I'm going to say mass times velocity. Well, what's the mass? It is, you can see in the video, 150 grams. So that is, I'm going to say 0.15 kilograms times 0.4 meters per second. And this works out to be, I want to say, let's see, 15 times 4 is 60. And how many decimal points do I have here? I think I've got 2. So 0.06 kilogram meters per second. That's the momentum of the cart on the left before the collision. The momentum of the cart on the right. So let me grab my other ruler and I will back up in time before the collision. I'm going to say, all right, well, maybe the leftmost part, excuse me, the rightmost part of my right cart is at the 20 centimeter mark. Notice that I reset my frames and clock, and I'm going to go forward until, let's see, oh, I don't know, right about there. The edge of the cart is at roughly 15, and the number of frames elapsed is 16 frames. So the momentum for this cart before the collision would seem to indicate that I need to know the speed, so it's 5 centimeters in 0.1333 seconds. How many meters per second is that? Well, let me get out a calculator. I'm going to do 5 divided by 0.1333, and I get about 38 centimeters per second, which I'm going to say is about 0. Oh, I don't know. We could say 3.8. I could probably round it and say, excuse me, that's meters per second, 0.4. The momentum of the cart on the right beforehand is going to be 150 grams, mass times velocity, right? 150 grams, or 0.15 kilograms, times 0.38 meters per second. And that works out to be, let me grab my calculator here. So let's see, I've got 38 times 0.15. So this here seems to indicate about 0.57 kilogram meters per second. But the key thing here is to recognize is that because these two carts are going in opposite directions of each other, they have to have opposite algebra signs, plus or minus. I like to say that anything moving to the left is negative. So the total momentum in the system would be the momentum to the right, 0.06 kilograms meters per second, plus the negative momentum to the left, which is 0.057. It's basically 0. Total momentum. In other words, we've got equal masses coming at each other head on. The total system momentum is roughly 0. Okay, now I'm assuming you could put that all into the tables and stuff. Remember, I'm not going to grade this. Now we want to verify that the total momentum in the system after the collision is 0. So I line up my carts and I say, oh, they're coming in, they squish, and then the instant, oh, see how they just stopped touching? The hoop springs are no longer touching. That means that they've stopped colliding. So I'm going to take my right cart here. I'm going to say 0 centimeters is at the very left, and I'm going to scroll forward some frames. Watch, ready? At frame number 0, I go from 0 to, let's say, 4 centimeters or so in 13 frames, or 0.1083. That looks familiar. So this is now after the collision. I'm going to say the speed of that cart on the right after the collision is 4 centimeters in 0.1083 seconds. So that's roughly 40 centimeters per second. And then for the left guy, after the, just after, okay, I'm going to bring my ruler over here. My left guy has its rightmost edge at the 0. I'm going to go, let's see, over to, let's say, 4 centimeters. And the left cart is going 4 centimeters in 0.1083. That is, oh my goodness, 40 centimeters per second, but it's negative. So I would say that the total momentum in the system after the collision is the cart on the right, which is positive 40 centimeters per second, positive 40 centimeters per second times 0.15 kilograms. The momentum from the guy on the left is negative 40 centimeters per second times 0.15 kilograms. We don't actually care what this momentum is because the sum is 0. So the momentum before the collision was 0. See that? And then the momentum after the collision is 0. And sure enough, the momentum was conserved. Now, this is a complicated calculation. You have got to be organized and keep your sort of mind in the bigger picture as you go through it. Okay, good luck.